Hello friends, my name is Akshay and let's start our today's GFG problem, which is number of distinct subsequences. So read the statement given a string consisting of lowercase English alphabets. So it's clarify that all alphabets will be lowercase. The task is to find number of distinct subsequences of the string. Answer can be large, so output will be modulo by 10 raised to 9 plus 7. So for this I take one variable mod which containing this value 10 raised to 9 plus 7. Okay, let's look the examples, which is GFG. We have to give an GFG, so we can create total 7 possible subsequence using this GFG. And how? Here it is written. If we have 3 GGG, so we can create 4 different subsequence. But how? So how can we count this? I will show you. But first let's explain this. If you have n elements which all are distinct, assume here is A, here is B, C, D and E. Okay, so in this case we have total 5 characters. So our total subsequence will be 2 raised to 5. Okay, so how? Let's see it. If you have empty string, so if you have empty string, so it have one empty subsequence. Okay, so if your size, which is n, is 0, so it means you have to return 1, because one subsequence are possible which is empty set. If you have n is equal to 1, okay, so if n is equal to 1, so consider in string you have only a one character. So how many subsequences are possible? So we can say that one is empty subset and second substring is the string by itself, which is a. So we can say that we have 2 substrings. Okay, if n is equal to 2. So we have total possibility of 1 is 2 and we have possibilities for 2. So total possibility will be 4. Okay, for this we have possibility, we take it or we don't take it. So we have multiply by 2 and here we have to multiply by 2 and here we have to multiply by 2. So total possibility is 1, 2, 3, 4, which is 2 raised to 5. Okay, so like this, if we have n elements, so the total possibility will be 2 raised to n. Okay, but this question is not simple, as here we see to returning only 2 raised to n and it will be answered. Here we considered all element are distinct, then we say that element total subsequence will be 2 raised to 1. But here we can see that in examples G repeated 2 times, here G repeated 3 times. So the answer will change, because if we use our formula which is 2 raised to n, so here GFG which is 3 and 2 raised to 3 will be 8. So in both cases we have to return 8, but we cannot return it, because if we look all combinations, so first we have empty set, so here it is empty. Okay, and after we have to take singles, so singles here G, F and G, 3 are singles. So in our case G will be 2 times, but we have to take G only once, so this 1 will be decreased, so 8 will be decreased by 1 and it will be 7. So we can look that in our total combination we just minus our repeating sequence. If we minus our repetition, so we can reach our answer, desired answer. Okay, like this. Here look again. We take one element G. Okay, so we have total two possibility, and then we take again G. So we have two elements. So for two elements we have total four subsequence, but we have to minus repeating. So G is repeating once again, so we minus 4 by 1. So total 3 possibility we can derive from this 2G, and we take third G. So we have to multiply 2 by 3, so which is 6, but after we have to minus this 2 times of G, so it will be 4. So here 4 is our answer. So we have to do which we say in code. First I take size of the string in n. Okay, I create one DP array which store the sequences, which store the values. For first sequence it will be 1, second it will be 4, and third it will be 8. In DP we will store at ith index, we will store the total subsequences. Okay, size of the total number of the subsequences we will store in DP. So we use dynamic programming. So I hope your fundamental of dynamic programming it is clear. Then you look for this question. Okay, and we have to look about the previous value. So previous value we use one vector last. I take size up to 256. Why? This is a ASCII code. If you look about ASCII code of Z, which is 19. Okay, so 122, the ASCII code of Z. Okay, so capital A have 1065. Okay, so if you find character of ASCII code 256. Okay, so you can look here, you can find here. So 256 I store for storing all A to Z alphabets. Here I counting the indexes, how many times this particular alphabet will occurs. Okay, I storing in this last vector. So we know DP is 0, it will be 1, because if our string is empty, so one subsequence are present, so I will take 1 here. After doing this, I use for loop, we starting with 1 up to n. Okay, why here I starting this one? Because 0th index is filled and we know 1, and using this I will derive all possibility of 1, 2, 3, 4, 5 indexes of DP. So we have to just multiply, which is in previous stage. Okay, but after multiplying we have to subtract rotations, repetition. Okay, we have to subtract repetition. So first we have to check if last of s of I minus 1 does not equal to minus 1. If it is not equal to minus 1, first we check here. If this is multiplied by 2, so it means we take one character g, and for this g character I will store the value 0 in this last. Okay, so I will do last of s of I minus 1 will be I minus 1. Okay, if it is present here 3, so I store for 2 because 2 are present here. So it means if our last is not equal to minus 1, so it means repetition are present, and we have to subtract repetition from this dp. I subtract, but here I have to take modulo, and here we have to subtract this. So dp minus equal to, what we have to subtract? We have to subtract this jth total subsequence. Okay, so we have to subtract subsequence, but last g's index, so it is stored in last element. Okay, of s of I minus 1. Okay, so s of I minus 1, it will returning character, and last array it will returning the last index of this g. Okay, and after finding this last index of g, I will give it in dp, and dp will returning the total subsequence of this, and I have to subtract from dp, and after subtracting, it will complete. Okay, here we have to also take one modulo, but if we don't take modulo, so it is not needed, and then return dp of I. Okay, here not I, but I compile this code. Is it working fine or not? Here it is working fine. Let's submit this code. Okay, so it is not working here. So what do I have to do? This is for, okay, it will reach to the max of the integer. So I have to write here, if our dp of n is less than 0, so dp of n plus equal to mod okay. So here also we take one modulo dp of I modulo equal to mod. I hope this code will work fine right now. Yes, this code is working fine. Okay, because after we decreasing this value, we have to do also modulo, and then I minus 1 in dp plus equal to mod, because sometime for this mod it will reaching some values which is more than max int, so it will be negative, as you know. So I increase with mod, so it give me correct answer. So thanks for watching this video. Please like, subscribe my channel. and share with your friends.